Uh, Hi. Today I'm going to explain about electrolysis, and I'm going to explain that by using several examples, only 4 examples, right? A lot of students ask for this video because they feel that it's quite confusing about how the reaction works. So this is it. I'm going to explain this electrolysis. Then in this video, I use a lot of picture. You can see the picture, download the picture. I already put it on Google Photo album. Yeah, and this is the QR code. You can open it up now, right? If you have your handphone now, you can open it up, and you can scan this and download if you need. Now I explain the basic of electrolysis. What is electrolysis? In simple term, we just say electrolysis is you have chemicals, you have solutions, but the solution doesn't react by itself. In chemistry, we call it we have a reaction that is not spontaneous, right? Non-spontaneous reaction. It means it doesn't react by itself. You must do something to make the reaction works. Some reactions are spontaneous, like acid-base reaction is spontaneous, right? We have acid and base, they can react together, then they will form salt and water. That's example of spontaneous reaction. Electrolysis is not. Yeah, it doesn't react by itself. You must force them, and you force them using a battery here, DC current. You have a solution, then the battery, you connect the battery to the solution by using 2 pieces of metal, one connected to the positive side, the other connected to the negative side. The one that is connected to the negative side of the battery is called cathode, and it's connected to the negative side. The one that is connected to the positive side is called anode, and since it's connected to the positive side, anode is positively charged, which means it will attract negatively charged ion, right? And it has a tendency to take electron away from element or compound, compound or ions, yeah? Because it's positively charged. So if you're taking electron away from some substance, then that process, we call it something redox, yeah? Sorry, oxidation only, it's not redox. Oxidation only, because the oxidation state increase, because you're taking away the electron, yeah? Now, this one, the solution is called electrolyte. As long as you have a liquid and the liquid can conduct electricity, then that liquid is called electrolyte. For us in O level or secondary level or IGCSE or yeah, we learn only 3 types. There's a lot of type of electrolyte, but for us, it's 3 only, the simple one. Molten electrolyte means you have an ionic compound and you heat it up until it melts, and you're not adding any water in it. And the example for that is sodium chloride liquid. Means you have a sodium chloride, which is a powder, solid powder. Then you heat it up, then it melts. After it melts, we call it molten electrolyte. In this case, molten sodium chloride. That's the first type. The second type is aqueous dilute electrolyte. which means you don't need to heat it up. You just add water. You have sodium chloride, put into a beaker, then you add a lot of water. And when you do that, you get dilute sodium chloride. You must add a lot of water so that it gets diluted. The third type is aqueous electrolyte. For example, electrolyte. Yeah, you put a lot of sodium chloride and you add only a small amount of water, then you get concentrated sodium chloride. And this electrolyte is connected to the battery using the electrode. Again, for us, we just learned two types of electrode, inert and non-inert. Inert means the electrode that is not reacting. The electrode does not react. Yeah, electrode does not react. And there are only two inert electrode, graphite and platinum. Non-inert electrode is anything, any other metals, anything that can conduct electricity. Yeah. For example, iron. Yeah, iron will not be, is non-inert, which means if you use that as anode, if you use iron as anode, the iron will dissolve. If you use zinc as anode, it will dissolve. If you use gold as anode, it will dissolve, right? So very easy. So you have two types. And why do we need to learn about these three types of electrolyte and these two types of electrode? Because it will affect how the reaction works. And the purpose of this video, for this video only, we are going to learn how to write down the reaction on the anode only. The next video, we are going to learn the reaction on the cathode. Yeah, anode only. Yeah, then we must know what reaction will happen when we do electrolysis of a certain substance. Yes, so that's it. We are going to analyze 4 examples. We are going to do 4 examples. The first one, a simple one. Both the anode and cathode are platinum. Anode and cathode are platinum. Yeah, that means, yeah. And the solution is dilute sodium chloride. What will happen? This is what will happen. You have 5 substance, 5 reactants. Yeah, what are the 5 reactants? First one is platinum itself. 2 is Cl minus and OH minus, Cl minus and Na plus. Why? Because you have sodium chloride. You have sodium chloride as the electrode, so it might react. Then the other 2, don't forget, is aqueous solution. So you have H plus and OH minus. So you have 5. Out of these 5, 2 will not react. Okay, out of these 5, you need to choose only 1. That means 4 will not react, but 2 of them is very, very unlikely. It's not logical at all. It's impossible for you to have that reaction. Which 2? Very simple. These 2. Na plus and H plus. They won't react. Reason? Very simple. This anode is positive. Yeah. This anode is positively charged. Na plus and H plus are positive. They will get repelled. They won't go near there. They will be repelled by the charge on the platinum. Yeah, and if you notice the reaction, Na plus turn into Na2 plus. Impossible. Okay, this platinum, this anode here is connected to the positive, and as a positively charged metal, what will happen? It has a tendency to take out electron from the neighboring molecule or ions or atoms. Yeah. So if you're positively charged, you tend to take electron away from people, which means the other three, the one that so-called still possible, the other three, PT will turn into PT plus because you take electron away from it. That means all the, you see, you notice the electron are all on the right-hand side. Yeah. PT turn into PT plus. Cl minus turn into Cl2 because if you're Cl minus and I take electron from you, you will turn into Cl2. OH minus turn into O2. You have 4 OH minus, I take 4 electron from them, then you're going to get oxygen gas. So you still have 3 possible reactions. And you should not stop there. You must choose one, right? You must remove 2. Okay, so left with 3. Which of these 3 do you think won't react? Very simple. One of them, you know. If you look at the notes here, PT, platinum is inert. Inert means it won't react. Very unlikely to react. So it's out. Left with Cl minus and OH minus. Which one? Okay, here's the hint. It's dilute. Dilute means you have a lot, small amount of Na plus and Cl minus, but a lot of OH minus. So don't choose the Cl minus. What will happen? The OH minus in water will turn into oxygen. So this is what happens. Yeah, in example 1. So this 4 reaction won't react. Especially these 2. These 2, for the next example, we don't even need to consider this because they are positively charged, right? So remember, in anode, the one that is positively charged, you don't even need to bother about checking that. Yeah. OH minus hydroxide ion will turn into oxygen, and what will you see? You will see effervescence of oxygen gas, colorless and odorless, right? Bubbles here. Yeah. So that's example 1. Then that's the reaction. Yeah. By the way, this reaction, we call it oxidation half equation. Because it's the oxidation only. It's not redox because you don't have the reduction, right? For redox, you must have the oxidation and reduction. Example 2, similar. Very, very similar. You have platinum and electrolyte is concentrated sodium chloride. Yeah, both the anode and cathode are platinum. We have 5, Na plus and H plus, we don't need to consider. So left with 3. Out of these 3, the platinum we erase also. It won't react. So between these 2, which one you choose? Very simple. You choose Cl minus because now it's concentrated. Concentrated means the concentration is high. So chlorine is more likely to react than OH minus. Yeah. So that's example 2. And what do you observe? You will see effervescence also. Effervescence means bubbles. bubbles of chlorine. What's the color? Yellowish green. Yeah, yellowish green gas. Example 3. Example 3 is similar to example 2. This time is molten sodium chloride, the electrolyte. Then anode and you have 5. Remove 2, Na plus and H plus. Left with 3. And platinum you erase also because platinum is inert, so it won't react. Left with Cl minus and OH minus. Very simple, very easy choice. This is molten. Molten means no water. No water. So there's no water in the first place. So there's no OH minus in the first place. So you must choose Cl minus. Yeah. What will happen? You will see bubbles also. Yeah. Yellowish green gas. Very simple. Example 4. Last example in this video. The zinc anode is zinc, cathode is platinum, and the electrolyte is concentrated sodium chloride. We have 5. Zinc, Cl minus, OH minus, Na plus, and H plus. Na plus and H plus, we remove that option. Then, out of these 3, which one you choose? Very simple. You must choose zinc. The moment you see the anode is not inert, you must choose that. The other 2 is less priority. Yeah, so remember, the moment you see the electrode is not inert, you must choose that reaction. You must dissolve that that metal. Yeah, zinc turn into zinc 2 plus 2 electron. Yeah. So that's it. We did 4 examples on the reaction of anodes only, right? Only on anodes. The cathodes will be on the next video. Right. Now we quickly recap. Yeah. Yeah, you can scan again if you need. Yeah. We quickly recap electrolysis, some chemicals that does not react by itself, you force them using electricity. You have 2 types of electrode, inert and non-inert. You have 3 types of electrolyte, molten, aqueous dilute, and aqueous concentrated. And in the first example, you must choose, okay, the Na plus and H plus, we don't consider that. Platinum doesn't work. Platinum won't dissolve because it's inert. For example 1, you must choose Cl minus because you must choose OH minus because the NaCl is dilute. For the second one, you need to choose Cl minus because it's concentrated. On the third one, you must choose Cl minus because it's molten and there is no water in the first place. On example 4, you must choose zinc because it's not inert, right? Okay. Please watch my next video about the reaction on the cathode. And by watching these 2 videos, you're going to learn more about electrolysis. Yeah.